Auto mesh. Terrain contour is a function of visual FEA, to generate meshes, over a terrain surface represented by elevation contours. The mesh region is defined by a series of boundary curves. The density of the mesh is determined by the divisions of the curves. The meshes are generated in the region mapped with the terrain surface. Let's make a simple example of mesh generation on a square area. Click the Rectangle tool button and create a square. Click the Curve Selection tool, and select the 4 straight lines of the square. Divide each of the lines into 20 segments. Choose Terrain Contour sub-item of Auto Mesh item from Mesh menu. Auto Mesh Terrain dialog appears at the right top of the window. Move the screen cursor over the square mesh region. The region is highlighted in green color. Select the region by clicking it. Then, Generate button is enabled. Click the button. Then, a file opening browser pops up. Select the name of the file, with a terrain contour data. More explanation about the contour data file will be given, in the later part of this tutorial. Open the file. Then, Terrain Adjustment dialog appears. The mesh generation can be completed, simply by clicking the OK button. Before doing this, however, let's examine the various functions of this dialog. The dialog has text items on the left, and graphic images on the right. At the top, there are the control items for image rotation, movement and scaling. The text items on the left include the coordinates, and elevations of the terrain contour, and mesh region. Setting the offset and scale of the terrain contour will be explained later, using another example. In the graphic image, the boundary curves of the mesh region are overlaid over the terrain contours. When the screen cursor is placed on a contour, or mesh boundary curve, it is highlighted in green color. And the coordinates x, y and elevation z of the point, at the cursor position, are also displayed in text. The minimum and maximum ranges of the terrain contours, and mesh region are summarized in the text lines below them. The center of the mesh region is marked on the graphic image. This is not the geometric center of area, but the midpoint of the horizontal and vertical ends. The three-dimensional view can be obtained by rotating the image, using the mouse dragging. Rotating the image further may reveal the contour layers of the terrain. After switching of the tool, the image can be panned by mouse dragging. Clicking the top view button reset the view direction. Now, click OK button, to generate the terrain mesh, with the current setting, shown in the graphic image of the terrain contours, and mesh region boundaries. The dialog is closed, and the mesh generation progresses. At completion of the process, the generated mesh is displayed on the screen. The three-dimensional surface mesh represents the terrain geometry. The next example will be used to explain how to resize, or reposition the terrain contour, relative to the mesh region. Let's repeat the same steps, to select the mesh region, and open the terrain contour files, and consequently to start terrain adjustment dialog. It is ready to set terrain contour offset and scale items. First check the x, y coordinates of the central point, by placing the cursor over it. Both x and y are equal to 20. Let's reposition the terrain contour by setting the x offset to 5 and y offset to 8. We can notice the movement of the terrain contour in relation to the mesh region. The center point of the mesh region remains unchanged, which is represented by a small blue circle. The same point of the terrain contour is moved to a new position, as designated by the x and y offset distance, and represented by a crossmark in red color. Placing the cursor over the crossmark shows the coordinates of the changed position. So, we may confirm the movement of the contour region. The scale of terrain contours is set as 1, in the scale text item, which implies that the distance scale of the terrain contour is identical to that of the mesh region. This scale can be altered by editing the text of the scale item box. For example, if we change the scale to 2, the geometry of the terrain contour is resized by the factor of 2. The resized positions are determined relative to the center of the mesh region. Thus, the x and y coordinates of the center are unchanged, that is, 20 and 20, the same as before. It is noted that the range of mesh region remain unchanged, while the range of terrain contour has been changed in accordance with the scale factor. Thus, the new coordinates of the offset point are 30 and 36. The offset distances are increased by the factor of 2, that is, to 10 and 16, respectively. Let's change the scale to 1.2. The graphic image is resized, but the position of the center remains unchanged. We may confirm the offset distance, resized by the factor of 1.2. Click OK button to generate the terrain mesh with this configuration. The generated mesh is displayed on the screen. Lastly, let's take a look at how to prepare the terrain contour file. There is a question mark button at the bottom of Auto Mesh Terrain dialog. Clicking the button shows the information about the format of terrain contour data. The information sheet has descriptions about data items for a simple example. Create numerical data representing a number of contour lines, using a text editing software. After completing the data file, save it as a simple text file with the extension .txt. Let's look over the contour data file, which has been used in this demonstration. Open the file with name, terraincontour.txt, for terrain mesh generation. And open the same file using a text editor this time, in order to compare the text data with the contours displayed in the graphic window. The first contour line has 11 points and elevation of 10. Placing the cursor over a contour curve highlights it in green color. Moving the cursor along the contour points displays the x and y coordinates of each point, which match the text data in the file. Scroll down the data text file to the part with 9 points and elevation 4. Place the cursor over the contour. Move through a point after another, along the contour, and identify the coordinates, in accord with the text data. This is the end of the tutorial for Auto Mesh Terrain Contour function.